Hi, I'm Chase. I'm a student at the University of Michigan.
Hi, I'm Kalyani, and I'm here from Mountain View, California, and I'm really excited to be here.
So as you saw in the video, for the hackathon, we created a project called Carbon Karma. So Carbon Karma specifically deals with carbon offsets. And just to give a little bit of an overview, essentially the way that carbon offsets work is that they allow carbon offset buyers, so people who are like companies that maybe want to have carbon neutral footprint, to buy offsets, which are from companies that are essentially carbon negative, or at least reducing the amount of carbon in the atmosphere. And so they pay money to offset providers, who then take that action. It can be a project that's negative polluting, or it can be a project that's working to innovate for the future of carbon offsets. So the problem that can sometimes happen here is that offset providers are not always able to be vetted in a really inexpensive way. So if you're a company that's reducing the amount of carbon in the atmosphere and you're doing really amazing things, you have to prove that you're actually doing that, and that can be really expensive. There are some ways to programmatically solve this problem, but they're really expensive or they're really hard to use. The other side of this is that companies then have to either vet projects themselves, or they end up not being able to transparently buy carbon offsets. And so we created a solution, which is Carbon Karma, which really solves three major problems. Number one, offsets need to be high quality, and that question comes into play. The second one is how we can verify that a buyer actually purchased offsets. So if you're a polluting company, you want to be able to prove that you did in fact buy an offset that's carbon negative. And the other piece is that how can we invest for electric drivers or other people who can really take big actions in their own lives? How can we make them want to invest and really get more involved to reduce their carbon emissions? And that's why we created Carbon Karma for this hackathon. So Carbon Karma really does three things. Number one, it rewards electric vehicle drivers, so they continue to want to drive their electric vehicle, but also brings in new electric vehicle drivers. Next, it allows renewable energy projects to be funded in a really transparent way. And it allows polluting companies or companies that want to be carbon neutral to really transparently and openly engage in this carbon offset market. So we did this by essentially introducing EV drivers, electric vehicle drivers, as vetting people who are looking into these carbon offset projects. And so the way that this works is when you drive your electric vehicle, a Karma, for example, you essentially get paid in tokens. And when you get paid in tokens, you can take those tokens and stake them in a project, a carbon offset project that you think is doing really amazing things. And so what you can then do is when that offset is sold to an offset buyer, you get 8% distributed among all the people who are staking of that cost. And so you're incentivized to find really great carbon offset projects. And a lot of electric vehicle drivers are already very engaged in making the environment really a better place. And so the offset seller gets 90%, the offset stakers get 8%, and then Carbon Karma, the entity, gets 2%. And that's essentially the business model. So you have electric vehicle drivers vetting projects to make sure the projects are doing not only what they say they do, but also continuing to innovate and really companies that are making the environment better. So electric vehicle drivers install a device in their car, which then reports that data. And those drivers just normally drive around as they would, and they're distributed car tokens, which they can then stake or sell in a marketplace for investors who also want to stake. So for carbon offset sellers, it allows them to not only get funding, but it also allows them to make sure that token holders are continuing to hold them accountable for their actions, and they can really easily sell their offsets in a transparent way for buyers who can then prove in a very open and transparent market that they did in fact buy those offsets, and that the seller is doing really great things for the environment. So it's very transparent as well. Now Nick's going to talk a little bit about how we implemented this solution.
Thank you, Chase. All right. So one of the things that we want to do in our solution is to make sure that it is as close to reality as possible. One of the problems we see in the current blockchain and cryptocurrency ecosystem is that there is a massive chasm between reality of mainstream users and what they're willing to tolerate and what blockchain solutions deliver. The complexity, things like mnemonic passphrases, private keys, etc., it's just too much for normal users to handle. So we wanted to step back a little bit and make something that was a little simpler. Our main thing was, how can we create a solution that is transitional innovation, that doesn't immediately force everyone to adopt something completely new and different. So we wanted to build on something that already existed, and that is this device called an OBD, an onboard diagnostics adapter. This is something that's been used in cars for the past 20 years, and it's very commonly available. There are many companies that make this. So what this does is it acts as a telematics oracle. So in the world of blockchain, an oracle is a trusted party that provides information for smart contracts. So there are many of these providers, and all of them have APIs. They typically work with a smartphone, and they can deliver data about their car. It could be everything from how many miles have been driven to is there a problem with the car, etc. We focus on the aspect of this device to tell us how many miles the EV driver has driven. So let's walk through exactly what happens. The EV driver starts off by registering their specific OBD device, which has a unique identifier, so we know exactly which EV it is. And that device gets registered, and once they start driving with that device and it's registered, the data is reported back to our oracle. Our oracle validates that data and ensures that it hasn't been tampered with, and then it passes it off to our smart contract. So once the smart contract gets this data, the smart contract is a standard ERC20 token smart contract, and what it does is it essentially generates tokens on the fly and assigns them to the user's wallet. Now, this is a slight different from most ERC20 token smart contracts, where you typically have tokens that have been assigned, etc. In this particular smart contract, the initial tokens are 0. They are essentially generated every time miles are generated. Now, how do we do that? Well, we did a fair bit of research into the tokenomics of this, and developed a model. Essentially, what we are doing is trying to reward the EV driver for driving with a vehicle that is not using fossil fuels. So we looked at the number of grams per kilometer that a fossil fuel uses of carbon dioxide, and then what's the difference between what an EV does. And we used that as the basis of our model. We also projected the model out to 2030, where there is estimated to be about 100 million EV vehicles on the streets. So using that, we came up with a good token model that assigns tokens per miles, and we came to essentially a token about every 6 kilometers. That's what we modeled it for. So one of the things that the EV driver could do right then is they get a token, assuming the smart contract token is listed on an exchange, they can immediately go and trade it, But the reality is that most EV drivers are not crypto traders. And also, this is a really boring thing to do. We need to do something more interesting. So what do we do? Well, let's look at what happens next. So within the platform, carbon offset sellers can come and register their project. Perhaps they have a solar project, or it might be a wind project, or something more interesting. Some way in which they are intending to generate renewable energy and reduce the CO2 in the world. So they come and register this project. And what the EV drivers can do with their tokens is they can stake those tokens on a particular project. And as the token stakes increase, they reach a certain threshold. And in the smart contract, we have an algorithm that figures out how many tokens need to be staked for the project that has been submitted to go from inactive to active. So once it goes to active state, that's when the project owner can start submitting listings. And those listings would be for carbon offset certificates. So the idea is now that a third party with carbon offset generating capability is in the smart contract. They have been approved by EV drivers by votes. Their vote is their tokens. They've staked their tokens. So what happens next? What happens next is once their listing is live, there are businesses that want to buy carbon offset certificates. So they're going to go and look through all of these and look at the ones that are most interesting, and they're going to look at the price that has been set, and they're going to pay that price. And that price is in ETH. So the buyers don't have to worry about tokens or anything like that. They just use standard ETH, and they pay for it, and they buy. Now, when the smart contract gets that ETH, it divides that up, as Chase pointed out earlier, where it retains 2%, that's for the platform, and then the remaining it divides up. 90% goes to the project that is going to generate the renewable energy. That becomes their funding. They can use that ETH immediately to pay for whatever it is they need to make their business get going. 8% of that ETH that was delivered to the smart contract is distributed pro rata to all the EV drivers who staked tokens. So imagine, if you will, that there are projects that are generating hundreds of certificates per day. So this is passive income that an EV driver got just for plugging in an OBD device and driving around. That they would have done anyway. So that's the beauty of this model. It works very efficiently. It rewards EV drivers for doing what they would ordinarily do, and it funds new projects that are designed to lower the CO2 in our world. So for the hackathon, we had 24 hours, maybe a little over 24 hours, 25 hours. So we built quite a bit of this. We essentially focused on the blockchain aspect of it because it's a blockchain hackathon, so we focused on that. So in less than 24 hours, we wrote about 1,000 lines of code and implemented almost the entire smart contract. We also implemented the Oracle and parts of the dApp. So the specific aspects of the smart contract that were a bit tricky were the calculations around minting tokens on the fly based on dynamic inputs from an Oracle, etc. But we got it done and we got it working, and we wrote a bunch of test cases, and so we could demonstrate at the hackathon during the judging that it really works well. For the Oracle, we just had to make sure that we had a mechanism by which we could securely validate the data, and we used the automatic API for that. So there's some code, you can look at it, but essentially we created one project that had all three. It had the smart contract, it had the dApp code, the front-end code, and the server-side API. The server-side API code is really throwaway because we wanted to make it decentralized, but just for testing purposes, it was easy to use some server-side code at the onset. So, and as I mentioned, we ran the tests, and this is what we demonstrated at the hackathon, along with a couple of screens and showing the Oracle, etc. But all our tests passed, and it worked quite well. The code that we wrote, again, it's 24 hours of work, so it's not awesome code, but you can find it on GitHub. It's already there at TryCrypto /carbon karma, and that was our solution. So we are really, really excited to participate in this hackathon and create something that is going to have a positive impact on this world. So thank you very much.
Thank you. So amazing delivery.